Another one, it's November the 2nd, not the 3rd, the 2nd. All right, let's take a look what we have. Minimum time to mark rope colorful. All right, let's do this. Alice has n balloons arranged in a rope. Give us your indexed string colors, where colors I is the color of the ith balloon. Alice wants the rope to be colorful. She does not want 2 consecutive balloons to be of the same color, so she asks Bob for help. Bob can remove some balloons from the rope to make it colorful. You're given a 0 index into your array need time. When you needed time I is the time in seconds, then Bob needs to remove the ith balloon from the rope. Return the minimum time Bob needs to make the rope colorful. Alright, so A, B, A, so this is a repeat, so this one needs to be removed. Oh, so if we have consecutives, we need to remove. Basically, we want to keep the one with the largest and find the second largest, right? We just want to find the second largest of the stretch. I want to. Right, so second largest is going to be 1, so this one will take 1. For 1, this one will take 1 as well. So 1 plus 1 is 2. So we're just going to go through them, and if it's the same, right, if this is the same as the previous one, we keep track of the second largest. And then once it becomes different, we'll keep track of the second largest. Ah, 1578. Keep track of second largest needed time. All right, for all the balloons. All the balloons are consecutive balloons. Oh, hold on. This is a Java. My bad. Shoot. Like, it doesn't make any sense. For all the balloons with the same color, all the consecutive balloons of the same color. What is that? Max. Second max. We'll call it M. Okay, and second M. Okay. And then what we said is if colors I is equal to colors I minus 1, in the time I is larger than M, then Sm equal to M equal to needed time I. Okay. Else if needed time I is larger than Sm, then sm equal to needed time I. Else, then we don't have to change. And here we have another else is current color is smaller than the previous, right? So smaller than the previous. Maximum actually should be needed time I, a 0. Right? So, they're not the same. You know what? I don't think that's right. I think this should be 0. Start with 0. Right? If it's the same, maximum is this. Second maximum. Actually, if they're the same, huh? No. I think it should be needed time 0, and this second largest is 0, right? The largest should be this, and then we say if it's larger than this, I'll do this, right? If it's smaller, if it's larger than this, which might be true, then we do this. But if it's different, right? If it's different. Now it's different, that means we have done. So we shall do res plus equal to second largest, right? Second maximum, and then move on. We move on by reset this to I, and this reset to 0. And then at the end, we'll return result. All right, let's take a look, see if it goes well. It does not go well with the last one. What was the last one? Output 1. Oh, I think I know, because once we're done, we don't have another one. So it should be res plus second largest. And then we shall say, give a little bit, m is the largest needed time, sm is the second max needed time. Yeah, let's call it not largest, is the max needed time. And if we do that, I shall be right. Okay, let's run it. Oh, that was so bad. Okay, let's see what happened. Yeah, that was bad. B, 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 A, A, A. We have 4, 9. Oh, my bad. He should be... Okay, yeah, this is completely wrong. This is completely wrong. I don't know why I do that. You have to remove all those, right? And each one removed needs to take time. So all we do is we keep the largest and then we remove everybody else. I don't know why you do it this way. There's no such thing as second largest. I thought we only need to remove one. We don't remove one, we remove all of them. That was so stupid. Okay, so we have to redo this. Basically, we need to find the largest along the way and then add all the others. So, okay, yeah, this is wrong. This is so wrong. All right, we need to find, basically, right, we find the max needed time for all the consecutive balloons. Then the answer is the sum of all needed time minus the sum of the max time of each balloon, right? Each set of consecutive balloons. All right, this is so bad. I don't even know how you get this. All right, let's redo this. All right, for int n of needed time, we say rest plus equal to n, so we get a baseline. And then we say for int I equal to 0, I smaller than, actually no, we need to do int m equal to needed time 0, and then this is starting from 1, smaller than colors size, oh, I don't know, size, huh? I cannot do colors of size? What the hell is that? Really? Colors does, I can only do switch. Oh, I forgot to do this, my bad. Yeah, I was like, why I cannot do it? Alright, and then yeah, I just say if colors I is equal to colors I minus 1, then we do m equal to maximum m and needed time I, right? Else that's different, then we say rest minus equal to m, and m reset to needed time I, and at the end we'll return rest. All right, this one should be right. Come on, that was such a bad first shot. Oh, this one is not right either. Oh, we only do it if it's multiple. Now you're removing all of them. All right, so we also need a count then. So we need a count 1, right? So I have to do this, count plus plus, right, else, and we shall say minus equal to count is larger than 1. If it is, we do this, otherwise we don't. And then we reset count equal to 1. Yeah, we have to count. If it's unique, we don't remove. I don't know, so much issues for such a simple question. And it's still not right. What in the world? Oh, we only want to know. Wait, we are taking away the largest, right? We say the largest is the ones we don't want to remove. Yeah, largest is the one we don't, hold on. Largest is the one we don't want to remove. Why you do count then? We do consecutive, we need to remove it. We need to remove it, right? Hold on. I think I am very wrong here. So if it's the same, I try to keep the largest, because the largest we want to keep, right? Largest is what we want to keep. And then once we get a different, then we shall remove the maximum, right? Because that's the one we want to keep. And then once we remove what's left, it should be returned. And of course, at the end, we shall do minus m at the end. We don't have count. I don't know why I struggle so much for this one. Doesn't seem to be that. Yeah, look, it's very simple. It's as simple as it can be. I have no idea why you struggle so hard. Right? It's very simple. Yeah, I don't understand. You know, sometimes it happens. I just don't know what happened. We do this. Yeah, it's about the same. We add one consecutive. This way we don't need to use the count variable. Yeah, I don't use the count. I do produce this one first and then I do remove. So I think it's about the same. Last time I did it, 2023 December. 2023 December. It's less than a year. No, it's more than a year. And the previous one is 2022. That was a long time ago, man. All right, that will be it. I will stop right here and